Okay, so yesterday we talked about the distributive property and we discussed that that was a multiplication property. And just a quick recap of it, our official definition of the distributive property states that multiplying a sum by a number is the same as multiplying each number added and then adding the products. And when we talked about this, I said, guys, this is a really extravagant definition. We're going to break it down and make it smaller. Today, we're breaking it down and making it smaller. So my way that I like to remember the distributive property is by calling it the Hippity-Hoppity distributive property. And before we get into the distributive property, let's just talk about a few examples up here. And let's follow our regular order of operations. So our very first problem, I want you to circle on your notes that X. That shows that we are multiplying. So my first step, if I was going to follow order of operations, I have to do all of the grouping first. So inside of my groups, I have 4 plus 6, which would give me 10. And then I copy down everything that I didn't use. So that would be the 3 in the multiplication symbol. And then my next step is 3 times 10, which gives me 30. On our next problem, this time I have a little dot right there. I want you to circle that dot. That dot also tells us that we are multiplying. So same thing, I'm going to follow order of operations, grouping first. So 6 plus 2 would give me 8. Copy down everything I did not use, which would be 5 times, and 5 times 8 gives me 40. And then on the very last one, this time I don't see an X and I don't see a dot in between the number 2 and that parentheses. So let's think if I were going to solve this following order of operations. First step would be 3 plus 9, which gives me 12. But if I got rid of those parentheses and I just wrote the 2, then it looks like the number 212, which is not what I've created. So I've got to put those parentheses back around the number 12 to show that it is separate from the 2. So I don't see any operations here. I don't see an adding. I don't see a subtracting, a multiplying, or dividing. Instead, our operation is invisible. So when I have a number that is directly next to a parenthesis and there is nothing in between it, that invisible operation is multiplication. So this still tells me to multiply. So I'm taking the number 2, multiplying by the number 12 for a final answer of 24. Okay, so the reason that I wanted to point this out is because when we do the distributive property, this right here is the most common way that you will see the distributive property displayed. There's going to be a number right next to the parentheses with that invisible multiplication in between. So for our first example, yes, I know it's the same problem 2 different ways. We're going to solve it using our official long distributive property. And let's start there. So the distributive property, remember, says that we can take the product of the add-ins and add those together. So if I was going to do the distributive property, I would start with 3 times 50 plus 3 times 6. And I could solve. 3 times 50 gives me 150 plus 3 times 6, which gives me 18, for a final answer of 168. Or I can start using my new trick called the Hippity-Hoppity distributive property. So what we're going to do is the number that is always on the outside, I want you to think of it as your little bunny rabbit. I'm even going to draw some ears on it. So my bunny rabbit likes to go hippity and it goes hoppity. So that number on the outside, that bunny, hippities to the first number. And what's happening is I am multiplying the number on the outside by the first add-in. So I would do 3 times 50 for a total of 150. Plus, my bunny still needs to go hoppity. So again, I'm going to take the number on the outside 3 and multiply it by the second add-in. So 3 times 6 would give me 18. So again, I end up with 150 plus 18 for a final answer of 168. So we got the same answer. I just took one less step to get there. So let's do the same thing with our second problem. Okay, this time I'm going to use the old school distributive property. So I'm going to rewrite it as 4 times 100 plus 4 times 8. 4 times 100 would give me 400. 4 times 8 would give me 32. When I add those two together, I get 432. This time I'm going to solve using the Hippity-Hoppity. So again, my bunny's going to go hippity to the first number. So 4 times 100 would give me 400. Plus, my bunny's going to go hoppity to the second number. 4 times 8 gives me 32. So I get a total of 432. Again, just a quick little Smith super secret math hack, a shortcut on how to solve those distributive property problems. Now, when we look at our next problems, I see the letter X somewhere in here. Now, we are getting to the point where we're going to start using letters in math. What? Those letters are called variables. So in math, we use variables, and the most common variables you'll see used are the variables X, Y, A, B, and C. But it can really be any letter of the alphabet. Those variables, what we're doing is we are representing an unknown number. So whenever I have a letter or a variable there, it's saying, hey, that letter X can represent any number. Now, later on, we'll learn how to solve for variables and figure out what they actually represent. But for right now, we're not solving anything. We're just saying that X can be any number. X right now could be 10. It could be 24. It's just representing a number that we don't know. Now, if I were going to try and do this with order of operations, my first step would be to do X plus 7, but I don't know what X is. I can't add 7 to something that I don't know. So I can't really follow order of operations here. And this is where Hippity-Hoppity distributive property allows us to still be able to simplify this expression. So again, the number on the outside is my bunny, and it's going to go hippity to that first added, which happens to be my variable. So whenever I multiply a number times a variable, it becomes the number and that variable. So it kind of looks like I just got rid of the parentheses. So 5 times x just becomes 5x. I'm going to add. My bunny goes hoppity, but I can do this one. 5 times 7, which would give me 35. So 5x plus 35 is equivalent to 5 parentheses x plus 7 parentheses. Same thing over here on our second example. I have 3 parentheses 2x plus 8. Again, if I were going to try and follow order of operations, I can't add 8 to 2 unknown numbers. I don't know what's happening there. So that I have to do the Hippity-Hoppity distributive property. So my first step would be 3 times 2x. So 3 times 2 gives me 6x. Plus, my bunny goes hoppity. I get 3 times 8, which gives me 24.